get it. Kind of scuffed right now. I was eating, and then honestly, it took a while to eat, and then I forgot, and I said, "Fuck it, I'll just finish this episode of Breaking Bad real quick," which is a mistake, but all right. Okay, I can have one glass on, I guess you say. I don't fucking know. I'm putting really hot water up against my eye so I can get this pimple to, like, I don't know, blossom or be poppable, something like that. Alright. Or, well, should have just done that. Should have copied that. Cool. Alright. So. Oh, yeah, we said that type deduction drops references, which might take a low level or a low level const and make which might convert it, or I guess it's not converting, but it would make a low level const become a high level const, because a high level const is a const that means the object we're talking about is itself constant, whereas a low level const means that the object we're talking about doesn't matter, but the object it is referring to. So we're talking about either a pointer, or that's really it, or a reference. So references can't be high level because there's no, the reference is an alias to the object. It's basically the object. That's what it is. So if we see a const reference, it's low level. But in this case, we have a low level const. We say a reference to a const standard string. Auto kills the reference. It drops the reference, which means, oh, now this is just a const standard string. There's no other object. This object is const, meaning that this is a high level const, meaning that auto type deduction will also drop the high level const too. So we end up just getting a standard string as this return value right here. Alright, let me get more water on it real quick. Did this big towel underneath it to catch all the excess, all the drippage. I don't really like squeezing out the water out of this that much because it's going to be hot for that much less of time. I want it to be hot as long as possible. Hot and wet for my eyeball. Oh, maybe that works. Right there? That works for now. Alright. Yep, we see that the reference is dropped, so we get a const standard string. This is a high level const. Fuck, it's not high. It's top level and low level. That makes no sense. It should be top and bottom level, but whatever. It's now a top level const, so it is also dropped, leaving the deduce type. The deduction is boom. Yep. So dropping a reference, yes, may indeed also drop the const. Same for no, not for a pointer though, because a pointer won't change it. A pointer refers to another place always and can be const itself. And because nothing gets dropped, doing a type deduction on a pointer will never drop the const of the type. We don't have to worry about that. In this case, we do have to worry about it though, because if we want to return a const value, like, I don't know, let's say we have a game and we have like a bestiary or something, right? It's spelled bestiary, but bestiary is better because you're literally putting beasts in it. You don't put fucking plants in it. You put animals, monsters. And you go and you kill a monster somewhere. Well, the monster's name and type is static. You're not going to find two different badgers and they're going to be pretend like what? There's a tentacle monster, okay? The tentacle monster's name is Tentacle Monster. That's it. They're all named Tentacle Monster. It's the same monster. You're just finding more of it. Like, you find a deer in the wild, you're not going to find another deer and be like, oh, it's a deer. A deer is a deer. A monster is a monster. Cool? So, the the standard string for the monster should be constant because we can't change the type of monster that the monster is. But you can't make me not a human. I'm a human. So, in the book, we have these different sections, just like a Pokedex, where entry 124 is the deer monster. That's it. There's no other monster. It's the deer monster. That's what goes to 124. And as you encounter them, it matches them up. Well, in the bestiary, each entry has a static string, a const standard string, because we can't change what monster is in entry 47. It's the tentacle monster. That's it. That's all it is. It's the freaking werewolf. That's all that 68 gets. It's werewolf. That's it. It's a question mark until you find werewolf and you skin it and learn about it, and then boom, now it's in your bestiary. So if we were updating the bestiary and we were saying auto, so once we discover a monster, we trigger update bestiary, or once we've killed the monster or investigated the monster, we've learned about the monster, we call update bestiary and we pass in a reference to the object we're talking about. In this case, it's the monster. It has a standard string. Let's just say the object is literally a standard string. Well, that's expensive. So we're passing a reference to read the value of the standard string. It's a const standard string, so it has to be a const standard string reference, a const reference. So, it's a reference to a const standard string. Okay? So, we're doing that. But the thing that we are updating, the bestiary entry, also needs to be a const standard string. So if we simply do auto for it, it will, drop the reference if we are returning a const standard string. It will remove the reference, so now we're not looking at that same piece of memory, and maybe that's okay. Maybe we don't want a reference. We want to actually copy the value from the deer monster into the bestiary. So there's a standard string in the object deer monster, and there's another standard string in the bestiary. So the bestiary is maybe like a list, an array of standard strings. Page 1 is this, page 2 is this, page 3 is this, etc. Or it's probably pages of objects, so an array of objects. And each one has a page number, an entry number, a standard string for the name, etc. A const reference standard string, just a const standard string, sure. And we pass that by reference, and then we take the return value. Really, I guess the return value we could just leave as const standard string. We don't really need it to be reference. Let's say we can't change the function because it's, what is it? It's like, because we don't want to get a reference to where the deer monster's name is. We want the actual value. But if we didn't, and we said auto in the bestiary code, auto, and then we call that function to get the reference to the deer monster's standard string, auto would drop the reference, leaving a const standard string because the standard string is const in the monster, so it's a const standard string. But then that's a high-level const. It's a const about the variable in question. It's a const about the object in question. The lowest level, the lowest level object. Therefore, it's a high-level const. It's a const about the object we care about. It's not a const about the object referring to the object we care about. So, in that case, auto would drop the reference, and therefore we would go from a high-level const, a high-level const about the object to no const. It would actually remove it because type deduction removes high-level const, top-level consts. Const? I'm just going to say const. High-level const. All right, I'm going to chill on the eye moisture. forgot, did not set an alarm. It should be, I've probably been going, what, 10 minutes maybe? So let's say if I go till 6:30, an hour and a half, that means I have to start my next time at 5. 4:30. How long have I been going? I don't even remember. 10 minutes maybe? Yeah. Okay. Started at 2:30. That's till 4. Start at 4:30 to 6. Hold on. Okay, let's go an hour and 20. Fuck it. Yeah. Makes sense. So, yeah, till 4. Alright. Hour and 20 left. Let's go. Okay, dropping the reference. Yes, may indeed change the low level const. Be a top level const, because now, if we're no longer referring to another variable, we're only. Yeah, if we're no longer referring to another variable with this variable, therefore, the const for this variable has to be high level, and it will get dropped by type deduction, which we can then reapply after. So we'd have to do return value. We would need to reapply both. So if we wanted just the value, we could make this guy const and say auto, get the value and make it const. This is what we would do for the bestiary example. But because maybe the bestiary stuff isn't always in memory, so we don't want to reference to it. So we do this. But if it is in memory, or maybe it's super expensive and we really don't want to copy it in 2 different places, then we can just put a reference to it. Cool. So auto drops both. We can reapply the const, or the reference, or both. Boom. Meaning the type after deduction becomes that. Oh. Interesting. So it's not actually. So auto applies to the whole line, seems like. Not just the value. The order of operations isn't clear. It's not obvious. So by default, drop the reference. If we drop the reference, then drop the const because it's high level. In this case, reapply the const, but not the reference. So we drop the reference, drop the const, reapply the const. Boom, boom, boom. In this case, normally the reference is dropped, thus the const is dropped, but instead, we put the reference here. So this is a reference to whatever the return type is. It's a reference to a const standard string. Okay. So that's a reference to something, and the to something is const. So we don't need to make it const because it's a low level const. It doesn't get dropped. And then we say, hey, these are going to get dropped, but we reapply the reference here, standard string. And thus this is a low level const and it's not dropped. But we could say const still to make sure it's clear. It's the same result. But then I don't have to look at the return type to see what type this is. I can just see, hey, this is const without having to go in to get const ref. Excuse me. Yep. Yeah, agreed. Reapply. Makes sense. Yeah, I agree. Doesn't change anything. Doesn't hurt anything. Okay, we get ref1 from getting a constant ref. If we get this, and auto is drop the reference. Excuse me, this is a const expression function. Drop the reference, drop the return type. It's a standard string view here. Const expression auto ref2. So this is normally dropped. We're not reapplying the reference, so this low-level const is dropped, but it's made const expression. Hold. Reference dropped. Top-level const dropped. Const expression applied. And const expression means const. And auto reference 3. Say, hey, don't drop this. Keep it. Is it const expression here? Or no, okay. Const expression is just because of here. Const expression is because of here. Okay. Isn't this like the same case? It's just that in this case we're dropping. In this case we're not dropping, therefore no drops. Boom versus boom. And then const expression. I've never seen double. What the hell? I've never seen that before at all. What the fuck? You can have both? I have never seen that. Can we do it with a regular string? Yeah. How would that work? Only if it's a const value? Could that work? Yeah, it seems like you have to have a different version of C++ in order for this to exist. Really? Standard string is actually an alias. Wow. Oh, so this is... We're viewing where this guy is in memory. Excuse me. So this isn't a const expression standard string, it's a const expression string view to something. Wait, what is this auto shit here? So the point here is that this has nothing to do with a standard string. There's no such thing as a const expression standard string. but there can be a const expression string view, because a standard string is, I guess, some sort of class, whereas a string view is a view to an object that might be able to exist at compile time, which in this case is this guy, which is a C-style string literal, which I guess can be const expression. And in that case, we were returning by value, but we could be returning by reference, which would just copy the value straight from there without having to. Oh, well. Hold. Excuse me. Oh, because this guy is oh, okay. So this, we have to explicitly say that this guy exists. Const expression standard string view hello is assigned x, and then we return hello specifically because it exists. Okay, so a C-style string gets created at compile time, or at runtime, seems like. Destroyed at program end. But I can explicitly create a standard string view initialized with it so that it actually does exist at compile time, seems like. Haven't seen this before. Type deduction does not drop pointers, which makes sense because we're not just looking at some other object and then dropping the pointer. We're looking at the pointer itself because the pointer is an object. Get pointer. Auto is a pointer to a standard string. Oh. It's the same in both cases, but we don't. The name would have to be, like if I had auto target, well, what is target? Is it a standard string? Is it a pointer to a standard string? You'd only know if you knew the code base, it seems like. Unless you make it a pointer already. Okay. So we can be redundant, sure. Does it change anything if we do? If I did some crazy looking stuff? Dang, I don't know what would happen. Can't have a pointer to an R value anyways. Is that what would happen if I removed that second asterisk? Never mind. That is not a thing. It would have to be a reference to it. No go. Okay. Yeah, exactly. Evaluating the object being referenced instead of actually evaluating an object looking at the object. Yeah, exactly. Not the reference, because the reference isn't an object. Yeah, so if we deduce a non-reference, we could just make it a reference again. But if it was forced, yeah, it would be deducing a reference, but then what would I have to do? I'd have to static cat. Well, because then auto would be deducing it as a reference. How do I remove that from auto? I can't just. Oh, I guess I could just try. I could try and convert it into its own value. Static cast, maybe. I don't know if that's even possible. Yeah, the pointer exactly. Yep. Yeah, is the pointer const or not const? The deduce type for auto does not include the pointer. Gotcha, meaning auto can drop it? Gotcha. If we have a pointer initializer. Or a pointer type initializer is what we call this? Ow. Gotcha. And it probably does that to avoid doing pointer pointer. If a pointer has an address, can I get a pointer pointer? I don't know if I've tried to look at this yet. Okay. What about int pointer pointer xpp address of xp? Oh shit! Excuse me. Can I do a pointer pointer pointer? Wait, no, but that's just a pointer. No, I guess not, is it? Uh-oh. Oh! It's cool with it? It doesn't care. Okay. Uh-oh. Oops. Wait. Oh my god. Oh, wow. Would you ever want that? I don't know if you'd. That is wild. So what if we did... Oh, it'd be too crazy. I'd have to do it for each one. As long as each one's not null. Holy shit. Do one and then add an asterisk to dereference again. So we have a pointer, dereference it, a pointer to a pointer, I dereference it to get the value of the pointer, and I dereference it again, two dereferences to get the value where the pointer, the value of the object the pointer's pointing at, which is a pointer, and the value that that's getting pointed at, which is the actual object. Wow. Okay. there can be some interesting cases. Okay. Oh, gotcha. Because if I'm returning it and it, what do you mean? So it doesn't return a pointer? So, oh, gotcha. Because if we use auto and we're not actually returning a pointer, like I change a function, I have a function and a bunch of calls to the function. The function returns a pointer. The auto calls deduce, hey, this is a pointer, and then does stuff with the value. But then I change the function to no longer return a pointer. Well, now those calls are still okay. Hold. Yeah. If they're just left auto. But if the calls were auto pointer and the function returned a pointer, we're cool. Because it's auto, so it's deducing the type that the pointer is pointing to. Pointer. Cool. But then it's a constant or whatever. But then it makes it a pointer. Well, if we're not actually returning the address of anything, then auto sees, hey, we're returning a standard string pointer, but only looking at the standard string part. But then the pointer part says this is a pointer to a standard string, but we're not returning a pointer anymore. We used to be, but not anymore. Uh-oh. So it's probably gonna be two cases, and it's gonna nope, never mind. Okay, let's see. So this is a standard string pointer. Returns a pointer. Hold. Oh. So auto will evaluate the standard string because we are dereferencing a pointer to a standard string. But in this case, if we're doing auto pointer and I dereference it, well, why would I name this pointer 3 if we're dereferencing this guy to get a standard string? Why would I name this pointer 3? I don't think I would do that. But in this case, we're dereferencing a pointer to get the value where it's holding. In this case, a standard string. So this can't be auto pointer. Excuse me. Yep. Yep. Type deduction and a const pointer. Is it because if we do auto, hold, oh shit. We might be getting some really interesting stuff. If I'm guessing, so if regular auto only, or it looks at the whole thing, a standard string pointer, const pointer, it will see const pointer and drop the const part and be, or hold. Yeah, and drop the const part, so it is a pointer to a standard string instead of a const pointer to a standard string. But if we say auto pointer, it's looking at the const standard string, which is a high level, or is the top level, because it's about the object. So it becomes a standard string, but then we add the pointer back. So it either keeps the const pointer or it just goes pointer. I'm not sure. So either we go from a const pointer to a const standard string to a pointer to a standard string or to a const pointer to a standard string. I think in this case we'd actually be losing the low level one in the context of the pointer. This could be crazy. Since pointers aren't dropped, we don't have to worry about that. But with pointers, we have both the const pointer and the pointer to const. Cases, okay. Only the top level, sure. So if we return a pointer, we get const auto pointer, we get pointer, but then it's added const. Cool. Or hold. We're making it const, so we say, hey, standard string, it's a const standard string. Or hold. Wait. Really? This returns a pointer to a standard string, and if we make it const, then it's a const pointer. So it's not a const standard string pointer. Auto sees that it's a pointer. So this is a const pointer. Standard string. A pointer to a standard string that's const. A const pointer to a standard string. An auto const. Okay, so same way. I kind of prefer it this way, honestly. Auto const pointer, because otherwise, if we put const auto, it makes it seem like this is adding it to the type that the pointer is looking at, but in reality, it's applying to the pointer, because auto is a pointer, const pointer to a standard string. But then, if we have auto pointer, we look at standard string, we make him a pointer, and then const, is it? Oh, because the const auto, the pointer definition initializer or something comes after. So it's, okay, auto sees standard string. But hold on. Auto pointer, when we have this, auto is only looking at the standard string part. Const standard string, pointer to const standard string. Auto pointer, hold on, means looking at standard string only. Then makes him a pointer. And makes him const? So standard string pointer const? Okay, Jesus Christ. So is 4 the best way? If we're trying to show that, hey, this has to be, okay, Jesus Christ. This is better, best practice, better say, don't fuck with it. Reapply, okay. Jesus. Auto const or const auto? For either. Because we're saying the pointer make him const. So I like auto const. Really? Inst const is fine? Or int const is okay? Standard string pointer, but now it's a pointer to a standard string, or a const pointer to a standard string. But if we say auto pointer, we look at standard string and then make it pointer. A const on the left means make the type, versus on the right probably makes the pointer. Wait, really? Oh, okay, yeah. On the left means pointer to const versus the right means a const pointer. Okay, good. I misread that for a sec. How you make a language like this in code so that it can tell whether something's on the left or on the right? Oh my god. Are you just checking characters to see if things are const and it's to the left and to the fuck, dude. This pointer 3 is a pointer to const, whereas pointer 4 is a const pointer. A const pointer to const. Holy shit. Standard string, a const pointer to a const standard string. Auto of pointer takes the const and it's a pointer to a const standard string. Yeah. And then auto pointer 2, well, that was a pointer to a const standard string. So we're looking at a pointer. There's no high level const, so leave it. Pointer to const standard string. But then we have an auto const versus const auto, same shit. We're looking at pointer. So we're saying auto. So we're looking at a const standard string. Hold. Auto. We're looking at the pointer. So we have a pointer to a const standard string, but the const is reapplied. We're looking at a pointer to a const standard string. No const now because auto drops the high level const. Reapply it. So it's a const pointer to a const standard string. The first one is better. 11 is better than 12 there because it's auto const, showing that we are reapplying not the standard strings const, but the pointer's const. And then we have, again, the better version 14. We're looking at, actually, no, maybe not. We're looking at auto. So we're looking at const standard string, which we drop. So in this case, 15 is better. Hold on. Actually, it depends. I forgot that it actually, in this case, auto looks at the const standard string. Trying to understand line 14 right now. Auto doesn't look at the pointer and it looks at const standard string. Let me try 15. Auto is looking at the const standard string, drops the const, but then reapplies the const, and then puts pointer. So it drops the high level one. Not sure how those 5 and 6 are working. I don't understand line 14 right now. So we're looking at pointer. It's a const pointer to a const standard string. Doesn't auto with the pointer? So when does the dropping happen? Because if it's not dropping the const standard string, then it seems like it's looking at const standard string, but const is reapplied to the pointer. So, a const auto const. Oh no. Oh, this is fucking my brain a little. Okay. When you use it, the type deduced does not include the pointer. It's the weird part though, using this when we have consts going on. Like this says standard string const pointer. So it seems like the auto evaluates and then this and then this. But I guess that's not totally true. So it's this pointer const pointer const pointer const type auto standard string. So isn't it looking at const standard string? Shouldn't it be dropping it? Oh, only, wait, yeah, but only top level const. Meaning that the low level const for a whole pointer will never be dropped. Okay. So in this case, auto looks only at const standard string, doesn't drop the const because we're talking about a pointer here. That's the low level const of the whole pointer. So this is a const standard string pointer const. A const pointer to a const standard string. In this case, auto looks at const standard string, not dropping shit, pointer with the type, not the pointer being const. So the assumption you have to make, or the fact you have to include to understand it, is that for type deduction, the low level will never be dropped from a pointer. Because then you have a pointer to a different type. You can't drop the low level const, yo. You can drop it for a reference because the reference itself is dropped. If it was only dropping the const, well, now you get a reference to a non-const, but you were starting with a reference to a const, and you can't do that because then you have a non-const reference to a const value, which is not possible because then you're changing the const. No, sir. And then down here, oh, because this is auto. This is not a point. Wait, hold on. This is auto. So a const standard string. It sees this and drops the high level const. So now it is a const pointer to a const standard string. Hold on. It's a pointer to a const standard string. Now it's a const pointer to a const standard string. Now it's a const pointer to a standard string. No. To a const standard string. But here, excuse me. But here we're saying const standard string pointer with a that's const with a const pointing type. I mean, I guess this is the most obvious, but here, trying to find out why this one doesn't compile. If it's auto in that case, it drops one. So if it's auto in the, oh, that's the point. So, or hold on. With the pointer part, we're allowed to specify both cases, even if it's extra. So in this case, const standard string. Pointer to it, const dropped, const reapplied, const pointer, const standard string, but with an extra const? No. In this case, const standard string only, const dropped, pointer to a const standard string that's a const pointer. Oh, hold on. So when we do it this way, we only keep the pointer const if we do this. So the point here is that both are dropped. When we look at auto, or wait, no, there is no drop for the const standard string. Auto const standard string pointer that's const with a const type. So this is like explicitly specifying the type, explicitly specifying the pointer type, and then already const standard string. Okay, it's interesting. Top level is dropped. The low level is not dropped because it's for low level in a pointer context. Top level dropped, reapplied. In both cases, we drop it but then reapply it, or don't. Which is already const. So it seems like we're allowed to say that the value we're pointing to is already const, and we can say that a bunch of times, but we can't make the actual object we're looking at, or the object const twice. Pointer 7, we're applying the const qualifier twice. So the point is I can have a const value, have an auto that deduces it, and then make it const. But I can't make it const, I think. It's already const, and I'm pointing to it, I can specify that it's still const. Which is allowed because it's a pointer type. Reapply the const even when it's not necessary. Okay. Consider using that. So that's obvious that it's a pointer type. Oh, true. And it requires us to use a pointer initializer. Yes. The headache. I mean, it's not a headache. I'm just getting sleepy. Okay. Oof. Top level versus low level const. Top level applies to the object, whereas the low level applies to the object we're looking through. Or looking at through whatever this object is, a pointer or reference. Yep. Drops references and drops top level const. Which will then be dropped. Then drops any top level const. Const expression is not part of the type system. It must be explicitly applied. Doesn't drop pointers. Doesn't drop low level from pointers. Okay. Oh, and pointers. When using auto, the deduce type will be a pointer only if the initializer is a pointer. Gotcha. Which is where we could get issues, because then it's not determining it from the right side, it's determining it from the right side and adding a pointer. Auto const and const auto are the same. Low level. Auto pointer const. Yep. Const auto drops the, yep. Const pointer. Int pointer const is a const pointer to an int. Yep. So same shit. It's a const pointer to a something. Const int pointer is a pointer to const. Oh, true. So const auto pointer is a pointer to const. Okay. Standard optional. Okay. What is standard optional? I need music. I gotta wake up. That shit got me tired. And I just ate too. Oh yeah, I gotta rewatch this. This looked good. Well, isn't this just fly? Aren't they just... Yeah, it's not actually... Well, I mean, it's showing a little, but... Alright, let's go. Standard optional. Handling errors. Function encounters an error that it can't handle itself, huh? Oh, like... Meaning, hey, if you get one of these errors, return this kind of code. Oh, like... Asserting that it's not divided by 0. Or we could do something else. Yeah. Hmm. Well, I mean, I would like to just assert in there that way we can. Well, what would happen? Like if we was wondering why this was wet. I mean, you could say that, hey, while that is zero, like if, excuse me, if y is zero, excuse me, return zero, and in your call to do in division, you can have a while loop that's saying, hey, while true, do in division, or rather, while or do while this, or well, I guess you wouldn't, because then it would just continue to do it. You'd have to get input again, huh? Yeah, is it successful? Or a value that's an error value. So we test reciprocal 5.0, negative 4.0, and 0.0. And test reciprocal as, well, one, it gets the result of double, and then it checks. Yeah, that makes sense. I was thinking like if you had a calculator like on Google and you open up the calculator, and if you somehow did something invalid, it wouldn't say, hey, get new numbers. It would just say, hey, you can't do this with those numbers. So when you're using it, you might then say, if that error happens, then it triggers you to get new numbers and then something else. So maybe some sort of recursion, like, hey, if you enter a name and then excuse me, like I don't know, if you enter a name that's inappropriate for a game, or what the people dictate is inappropriate, then, or it matches somebody else's existing name, then it continues prompting you for input. So something like that, where it says, hey, you tried to divide by zero. Sure, 5 and 0 are valid inputs. We can add 5 and 0. Okay. We can't divide 5 by 0 though. So it just continues, and you can backspace to remove the input or add new input or something like that. So it would make sense that the caller would be handling it. I think so. Yep, so we say the reciprocal of, let's say in this case, 5, so 1 over 5 is 0.2, is, well, the result isn't 0.2, or isn't 0, so we say it's 0.2, okay? But then we do the same thing for negative 4, 1 divided by negative 4 is that just negative 0.25? Something like that? And then, yeah, because negative 4 times negative 0.25 it should be just 1. And then we do 0. Oh, 1 divided by 0, no sir. If it's 0, return 0. Cool. And then we say, hey, it's undefined. The programmer must know in order to make the code that handles it, sure. Hmm. Yeah, yeah, true. Yeah, it's hard because, like, what do you do? Return 0.5 or something, but then that just gets converted to 0 if we go for an and to get a narrowing conversion. So, sentinel values, what else do you do? Ow. Yeah, true. Because, oh yeah, true. Because if we said 0, yeah. But in that case, 1 divided by nothing gets 0. Can't divide 1 by something to get 0, but we can divide 0 by something to get 0. Okay. Yeah, that seems like that's just stupid. The lowest number for an int, that's negative 4 point something million or billion. I don't know about that. And then you would still just have to be like, hey, this is an unexpected answer. Okay. Yeah. The most negative value for type D, yeah. Gotcha. Why isn't it min? Yep. Excuse me. Wait, how the fuck did time pass like that? It was 10 minutes not long ago at all. What the hell? How did it pass like that? Feels like I just did a time skip in a game. Witcher. Or Kingdom Come. Yeah, we need to make sure. I mean, if we're testing it like that, then we have to say, hey, is it the same? Is it the lowest value possible? Then do something. It's an example of a semi-predicate problem. If we call that oh, gotcha. Because if they call the lowest, meaning we can't tell whether it's yeah, exactly. Yeah, that makes sense. Well, that's what I was saying because I was thinking that even if we didn't do this way, we just said instead of doing standard numeric limits lowest to get the lowest value, if you just happen to know it, like the lowest, well, I guess it would depend on the architecture. So that's probably not the best. That's not the best way. Because then you'd overflow it on lower architectures with smaller bits, like 32 versus 64. Well, your int is this many bits or bytes versus this many. If you put in negative something billion, then it's going to overflow in that architecture, and then you're not getting what you want. So, if the user happened to enter the value that is the lowest, then we don't actually know if, like, if it's something divided, or let's see. Yeah, like, there's no way to tell if it's a real error or not. Because if someone just multiplied two things, fuck it. Negative 4,868 times 4 million something. Oh, well, maybe you get the lowest value possible. Are they just doing a product or are they just dividing? Are they just doing a reciprocal of an even bigger number? And it turns out that you have an int64 in there, which gets converted. I don't know. Well, yeah, I mean, the reason here is that we're saying, hey, we have a sentinel value in order to indicate whether this function succeeded or failed. The problem, though, is that the sentinel value is a valid value. You have to do one that isn't valid, or that isn't a possible answer. So what? Then do we have to pass in out an in out well an out parameter boolean and two ins for x and y, and then the out. Oh. To return two values. I mean, it seems like you would have to do that via references or pointers. That implements an optional value? What? Excuse me. Excuse me, gotcha. Meaning it can return a Boolean or it can return the actual value, so we could compare it to true, and then if it's a Boolean by itself, then, if it's true, if it's not true, something like that. And so the optional is return nothing, null option, meaning that that is our sentinel value. So we say return the optional or an int. So we want an int, but if they fuck up, then it returns the optional. Gotcha. Yep. And then we say, hey, we have to call it as is. We have to explicitly specify, I guess it's not a null parameter. Or, oh, we're actually creating an object? A standard optional int result? So it might be an integer or it might be this? Jesus. So if we say... So if result 1, if it's true... Oh, so is it a true or false? It's returning that, maybe? Reminded me of guitar for some reason. And so for the first one, it gives a number, and the second gives a fail. So it's a Boolean or a that. And we check to see if it's true or false. If it's true, then there's no error code, or it succeeded. And if it's else, it failed. Oh, and we return a dereferenced optional? So it... The fuck? So it's like it's returning this value, but pointing to this one. So if it's true, we go and get that value. If it's false, we just say nothing. Is that all it is? Optional? It is. Huh. We want it to return an int. We use standard optional to make sure that we can have a sentinel value. If it's greater than 100, return that. Return a null option. And so, are there two places of memory? Is there, oh, does it create a temporary? Oh. So it's really returning a pointer to this. So standard optional is a pointer to the result, or well, it's like a hidden pointer to the result, but it's really a Boolean, so we can check. If we evaluate it, it's true or false, not an address. But if I dereference it, I get the result of a pointer. A dereferenced temporary seems like maybe. But it's not a temporary? I'm not sure how this actually is going. We're outputting curious. Uh-oh, two things. Oh, wait, it's actually okay? I'm surprised. Now, what if we do 102? Oh! Oh, there's an assert built in. So we assert, well, what is it? We assert, oh, the value of an empty optional. Okay, abort. Interesting. The value of an empty optional. Excuse me. I was trying to see if those are two quotes around it, and that is. Empty optional value, yeah. So we're dereferencing an empty optional. And I guess that's how we can check. It's kind of null-ish. I don't know what we call it. It's not null pointer, but it's like a pointer to some empty thing. Saying, hey, Don't go over here. This is where the value is if it's not real. So I guess we return an empty optional. Empty optional. And so what? It's returning nothing to this location in memory, or it's returning this value. That way we can dereference it to get this value, or we can dereference it and we get this value. But it returns a boolean that we can check. What if we just do that and then see? Oh. Can't do that. Huh, okay. So it returns a this or a that. You somehow, in the name thing, you somehow entered an invalid character, and we are returning a standard string that appends all those characters, but we don't want an invalid character. Then if you entered an invalid character, I guess we can go through the standard string and check, is there an invalid character? If there is, return this and fail it instead of returning the actual thing. Let me think about other use cases. Standard optional, huh? Let me look more into here and then I'll find out. So we have a function called do division. It optionally returns an integer, or it fails with a boolean, and we can handle it that way instead of having to return a sentinel value. This is our sentinel value. I guess this is. Can we do multiple types? I don't think so, because it's only... It's only one type. Nah, the template doesn't allow us to do int, bool. Nope. Nope, too many arguments for the template. So what would that template even look like if it was programmed in standard optional? It returns a type name. It returns I've never seen something like this, where we have an object type with a template thing there. Like a non-type template parameter is what it looks like to me. But normally that's here, and we specify that in a call, but we're not. It's actually the return value. It's returning a this or a this, meaning that this is a this or a this. Huh. Well, if we say... Cannot output this guy. Cannot output an actual optional. We can only check to see if it's true or false. I could do that. Uh-oh! There it goes. Okay. So then it would depend on the parameters here then. Unless it's accessing something else, it needs some sort of condition. If we always return this, then it's useless. So I can't output it to get true or false. But the condition evaluates to... Oh, well how about we do if value. Fuck! I wanted to see what the debugger looks like. Fuck! Wait, how am I actually making good time? This is a full hour and a half times 2 so far, and then I have one more. I don't know how that worked out actually. We don't see anything here. This is weird. Oh, null option. And null option, if we evaluate it as a condition, I guess it evaluates to true or false. What if I... Is this okay? Uh-oh. Can't do it. Okay, so if it will return, if it didn't return this, it evaluates, it executes an if condition. So I guess it's the condition is true, but we can't actually compare it to true. Null opt is a mystery. Okay. Okay, do that later. Time to upload this thing. Asmongold. Alright, see ya.